So what we want to try to look at is the difference between explicit and implicit functions. And one other question that we have to ask ourselves is, are we able to write an explicit function as an implicit function? Or are we able to write an implicit function to be explicit? So what I mean is that if you're given a function, okay, if you're given a function, are able to if you're given a function that is called to be explicit, are you able to write it as implicit? Or you're given a function that is known to be implicit, are you able to write it as an explicit function? Okay, so the main difference from the definition point of view, or from the theoretical description point of view, in terms of the difference between the two, is that when you're talking about an implicit function, okay, maybe before I do that, let me try to write down some examples. So let me say I'm given um, something like y is equals to, let's say, x squared plus 2x plus 1. Okay, then let's say we also have something like uh, let me say x squared minus uh, 3xy plus y squared minus x is equals to 0. So when you're talking about an explicit function, so an explicit function is one in which the dependent variable can be expressed in terms of the independent variable. So what we mean is that you have the dependent variable, in this case, which is our y, which can be written or expressed in the form of or in form or in terms of its independent variable, which is x. So what it basically means is that our y is the dependent variable. It depends on the independent variable, which is what? Which is x, that we have put this side. That is what it means. So if we're able to get a function, whatever, in whatever form, for example, if this could have been given in the form, let's say, x squared plus 2x is equals to y minus 1, I could have been given in that form. But if I'm able to write that function, if I'm able to get this function, then I write to say, okay, I only write it in terms of y. This is just going to be y is equals to x to the second plus 2x plus 1. This becomes an explicit function because I'm able to write my dependent variable in terms of its independent variables, which is x here. So our y depends on our what? Depends on our x. But if I have a situation where I guess this goes to implicit. Let me first of all define what implicit functions are. So when it comes to implicit functions, implicit functions are just those where um, we cannot write one variable in terms of the other. Like we cannot get a variable that we are going to call to be a dependent variable, then we write it in terms of its independent variable. So it's like we have two variables here, we have x and y. So what you observe is that you cannot at any point write maybe y in terms of x or x in terms of y, simply because of what we have right here. Okay, and another thing that you have to keep in mind is that I can give you something like let's say I can give you 2x squared um, plus y squared, let this be equals to 4. That is an ellipse. That's the equation of an ellipse. This that you have right here is an implicit function. One might debate to say, oh, why are you saying implicit function when I'm able to write this as an explicit function? Well, it only becomes an explicit function if you write it to be an explicit function. But the way it is in this form, it still remains to be what? An implicit function. Provided uh, you have like the whole function itself is a combination of the x and the y variable. It remains to be an implicit function. And again, let's say I say, okay, I say y squared is equals to 4 minus 2x squared. Then does this now become an explicit function? The answer is no, because what you are supposed to write is a variable in terms of another variable, not that variable squared, or that variable to the power 3, or that variable to the half or something. So the fact that I don't have a 1 here, this still remains to be a, this still remains to be an implicit function. So for me to make this to be an explicit function, I need to write it in terms of y alone, not y to the power 2, y to the power 3, or y to the power any power besides 1. Okay, so here this is just going to be y is equals to the square root of 4 minus 2x squared. This now becomes this now becomes an explicit function. To write it in this form is the same as writing it in that form. It's just more like you just rearrange them in a certain way. So provided the power of y, okay, provided the power of y is not 1, is any other power such as a 2 or anything greater than that, or less than that, but 1, it remains to be an implicit function. And another other conditions that other situations where we have implicit function, it becomes more clear when you're talking about rotation of conic sections, equations that are of this kind, whereby you have an x term and a y term together. Okay, let's say for example you have your xy is equals to 2. This is an implicit function. It only becomes an explicit function if I say y is equals to 2 over x. So meaning my y is my dependent variable, then my x is what? Is my independent variable. Then you might also find a situation whereby this equation that you have here, you might say, okay, let me try to write this in terms of y. And for some functions, you have to take note, for some functions, you cannot write them as explicit functions. They remain implicit functions just the way they are. For example, this one there, this one that we have here. So you observe to say, if I take this y squared here, I say y squared, let it be equals to x, this x here, then I say plus the 3xy minus the x squared here. Then you might want to say, okay, let me say y is equals to the square root of x plus 3xy minus x squared. So this still remains to be an implicit function. Why do I say so? Because you still have a combination of an x and a y term right there. Okay, so now before I end this video, you might wonder why to say, like, you might wonder why it is important for you to be able to know which one is an explicit function, which one is an implicit function. This makes a lot of sense when it comes to differentiating. Like it's either you're differentiating implicitly or explicitly. So by us understanding which one is an implicit function and which one is an explicit function, implicit differentiating or explicit differentiating is going to be much easier. And of course, there are some equations. That you're able to differentiate implicitly and explicitly. You're still going to get one and the same thing. It's just a matter of you choosing which one is going to be the subject of the formula of that particular derivative or the gradient function that you're going to have. So that's all in this video. Thank you very much for watching.